All right, so here I am continuing our piecewise function notes. I'll be doing this section on evaluating piecewise, and then also I will be doing the application problems. I'll try to keep this short and sweet. Whenever you have any function, actually not just piecewise, and they tell you to evaluate the function with a number instead of an x in our function notation, all you have to do is plug in that number for x. So here on this first example, which I'm probably only going to show you one, so I'll show you the second one over here, and we'll skip this one for now. If you want to know how to solve this number one, I will be posting my teacher key so you can look there as well. All right, so we're evaluating f of -1. So we have to look, okay, which one of these functions does the restriction include -1? So our first restriction is for x less than 1, which -1 is less than 1. So we would be applying this -1 to the first line of function. So f of -1, we're applying to the first line. So we plug in -1 for that first x there. So we're first squaring -1, which it becomes a +1. So this is 4 minus 1 would just give us 3. So f of -1 is equal to 3. Now we keep going. And we're now going to look at f of 0. So we ask ourselves, okay, is 0 less than 1 like this, or is it greater or equal to 1? Well, again, it is less than 1, so we are using that first equation. So f of 0, we're going to plug in 0 for x, which 0 squared is 0, and so 4 minus 0 is 4. So f of 0 is 4. Then, oh, why did I erase that? So our green function was that first, and then the red was again the first. So now let's do blue. We'll do f of 2. 2 this time is bigger than 1, so I'm now going to be using the second equation. So f of 2, I plug in 2 where I see an x in that second equation this time. Whoops, I was about to write 3. 2 plus 1, I'm plugging in 2 where I see the x. So this is 2 plus 1 is 3. Now normally I would tell you leave it in radical form, square root form. However, these are our y values actually. We're ending up with f of x values or y values. So technically we may ask you to plot this on a graph, which it'd be really hard to understand where the square root of 3 is on the graph. So we do want it in decimal form. So I just plug in the square root of 3 in my calculator, and I get 1.732. So f of 2 is 1.732. And then what color? I'll do pink next. F of 4. So 4 is bigger than 1, so I'm again using that second line. F of 4 is equal to, and I plug in 4 where I see an x, so it's going to be 4 plus 1, which is 5, so it's the square root of 5, which the square root of 5, plugging in my calculator, I get 2.236, which of course I am rounding here. I'm rounding to the thousands place. My calculator gave 2.236067977, and I'm just rounding to the thousands place. And then lastly, I'll do this one in purple, f of 6. So 6 is again bigger than 1, so I'm using that second line and plugging in 6 for x, and I have the square root of 7, which plugging in my calculator, I get 2.6457, so the 7 makes the 5 round up to a 6 actually. And that's how you evaluate functions for specific x values. You just plug in to the x value and you determine which function, which line of equation you're plugging into based on the restrictions. All right, So now moving on to the application problems. Our first problem states your dog groomer charges according to the following function, with f of x representing the total price and x representing the weight of the dog in pounds. So part A says, if your dog weighs 15 pounds, how much will you pay? Remembering that x represents the weight. So if our dog weighs 15 pounds, that means I'm looking at which restriction includes that 15. So it looks like my first restriction includes 15. It's less than or equal to 15. So that means if my dog weighs exactly 15 pounds, I will be paying $35. Then it asks if my dog weighs 35, so I'm looking, okay, in my restrictions, which one of these, 1, 2, or 3, would include 35? Well, it's between 15 and 40. So if my dog weighs 35 pounds, I will pay $40. Then if my dog weighs 56 pounds, how much will I pay? I have to look which one of these includes 55. Well, 55 is greater than 40. So I'm going to be using this last line, which it looks like for this one, I do have to plug in the number of pounds. So that's what I'm going to do over here. I'm going to plug in 56 for x because that's how much my dog weighs, which is about right. Ghost weighs about like 50 to 55 pounds. So 2 times 56 minus 40. So 56 minus 40 is 16 times 2 is, what did I say? 16 times 2, 38. 32, sorry, my God. And you add 40 and you get 72. My gosh. It does not pay to have a heavy dog. And then what is the domain of this function? What is the range? So the domain is looking at your x value. So you look at your restrictions. We start at 0, but notice it's not equal to 0. You're not going to have a 0 pound dog. So our domain starts at 0, but it's not equal to 0. So I don't put a bracket up to infinity. And then my range, that's my y values. Again, you look at your f of x values, which are given by your equations. The lowest price that you could possibly pay is 35. And it is equal to 35. So you put a bracket to infinity. Which I know reasonably you won't have a dog that is infinity pounds large, but you can't like pinpoint exactly how large. So you would just say infinity. Okay, next. Your cell phone plan costs $75 a month and gives you unlimited talk and 500 text messages per month and no data plan. After 500 text messages, it costs 10 cents per text you send. So there are 2 different things that you could be paying here. One is just $75 a month if you are under 500 or lower. And then if you go over $500 or 500 text messages, it costs 10 cents per text after that. So let's create our piecewise. Let's see. Cost per number of minutes we'll do. So it costs $75. Whoopsies. It costs $75 if your number of minutes is between 0 and 500, which I did include 0 here because I said minutes. Number of text messages, because you could send 0 text. That's totally plausible, but regardless, you are going to pay $75, even if you never text once. Then for the second line, you are, let's see here. So you're paying 10 cents per text you send after 500. So this means that if you, for instance, text 550 times, you send 550 text messages, you're only for that additional 50 going to be paying 10 cents per message. So you want to basically subtract the 500 because you're not paying 10 cents for the original 500, right? You're only paying 10 cents for the amount that you go over 500. So you would do the number of minutes minus 500. But then this is in addition to your 75. You're still paying $75 basically for that original 500. So you add 75 to that 10 cents per additional minute. And this is if you go over 500. That's an awful 500. All right. So that's our piecewise function. And then it says, what is your domain? So your domain, your number of text messages, you can send as many texts as you possibly could dream of, but you are going to pay 10 cents for each, but that doesn't affect how many you could possibly send. So you can have 0 text all the way up to infinity. And then your range is the amount of money you're going to be spending per month. So the lowest you could possibly spend is 75. But then depending on how many texts, you go all the way up to infinity. And lastly, at Texas College, tuition for in-state residents were $92 per credit for the first 10 credits, $35 per credit for credits, oh my God, $35 per credit for credits 11 through 18. And for over 18 credits, the rate is $74 per credit. Write a piecewise function for the total tuition T at Texas College as a function of the numbers of credits C. So it wants us to define this piecewise as T of C. So we are going to be paying $92 per credit. So that means $92 depending on how many credits we have for the first 10 credits. So that's only from 0 all the way up to 10, including 10. But then it's $35 per credit for credits 11 through 18. Now we're not going to be spending $35 for all the credits, only the ones that are greater than 10. So we want to actually subtract the first 10. We're not applying the $35 to all, just the ones over 10. So we want to subtract 10 from the number of credits. But then we can't forget about those first 10 credits. So what we do is we figure out, okay, how much did those first 10 credits cost us? Well, 10 times 92 is 920. So the first 10 credits cost us 920. So we need to add that on to our bill. And this is for our credits that are bigger than 10, but less than 18. Less than or equal to 18. And then our last line, we're paying $74 per credit over 18. So we're not paying $74 for all of our credits, just the ones bigger than 18. So I need to subtract from my number of credits 18 away. So say I was taking 20 credits. It would be 20 minus 18. So I'm only applying 74 for those 2 credits. But then I still need to include the previous 18. So what you do here is you plug in 18 to the previous line. So 18 minus 10 is 8. Let's see. 35 times 8 is 280. Adding on the 920 for the first 10 credits. So that's 100, or oh my God, 100. $12,000 for the first 18 credits that I also need to add on to my bill. And this is only for credits bigger than 18. So this is my piecewise function. This is what I end up with. This is also crazy cheap for credits. Try adding another 0 to all these numbers. Okay, so let's see here. What else does it ask? Be sure to consider the reasonable domain and range. So our domain is our C values, right? Our X values or C values. So you could take 0 credits. That's totally plausible. That means you're really not enrolled. So actually, is it reasonable to say you're taking no credits? I say no. Then you wouldn't be enrolled. You wouldn't be going to college at all. So I would say you don't include 0. All the way up to infinity. And then your range is, again, 0 to infinity. And that's it. Wow, I finished that in 15 minutes.